Hello, people on the internet. Thank you for coming to our talk. I think we could probably bring the slides up now. That would be good. Right, yeah, so thanks for coming. We're going to be doing a talk on about consuming some observability features in Node.js and how maybe we can get access to those in a Kubernetes environment. Before we kind of start with the talk, I feel like we should do some introductions. So, Alex, if you want to go first here.
Yeah, sure thing. Hi everyone. My name is Alykiotis, and I am a junior software engineer at Red Hat. And more specifically, I work in the Nodejs project. I use it very rarely, so this is why I added my GitHub username instead there. Some random facts about myself. A couple of years back, I became a massive Formula One fan, and I'm still going strong. And JavaScript aside, I really like to play around with Rust and F#. Cool. Because we are all remote here, I thought it's a good idea to share where I'm currently at. I live in Athens, Greece. Greece, for those of you who don't know where it's located, is in the southeast part of Europe, and you can also see that on the map. Exactly where this red arrow is pointing at. Cool, I think that's enough information about myself. Let's switch back to Luke so he can also introduce himself.
All right, thanks, Alex. Yeah, so my name is Luke Holmquist, or if I guess on the title card it was Lucas, but either is fine. Yeah, so I'm a software engineer at Red Hat, like Alex. I'm also focused on the NodeShift project. That project we're aiming to help developers create Node applications on OpenShift and Kubernetes and stuff. So we're at nodeshift.dev if you want to check that out. You can find me on Twitter at Sienna Luke. Although also just a few random facts about myself also is I'm a huge fan of the band Fish. So if you like them and want to talk music, find me on Twitter. I'm also the current title holder of the Star Wars trivia at my local library and know entirely too many facts about probably the original trilogy. So again, if you're a Star Wars nerd like myself and you want to talk Star Wars, I'm also on Twitter. And I also got my little Yoda guy. He comes with me for every talk, although he hasn't traveled recently, but he's always there. All right. So, yeah, and like Alex said, since we are remote, I feel like I should probably tell you where I am. So I live in upstate New York. If you're from New York and you're watching this picture will make sense to you. If not, it's a cool picture. Right, yeah. So all right. So enough of this stuff. Let's get into this talk. All right. So congratulations. You've deployed your application to production. Nice job. Awesome. Most likely in some sort of container platform like Kubernetes or OpenShift or something like that. And at the moment, your application is working pretty well. Your users are pretty happy and everything seems to be going pretty well at the moment. So now what, right? It's like, how do you keep your application running and how do you keep it running well? How do you keep those users happy? So a key part of this now what question is being able to observe what's going on within your application. So for example, like how many resources is your application using? Like what's the CPU usage? Is your application calling some sort of function that's blocking Node's event loop and it's blocking everything else, causing users to wait longer and longer than expected? Did a large windstorm come through and make your application block other applications from being deployed, costing your customers millions of dollars a day? I don't know, maybe. So being able to determine these things when they're outside of kind of the norms, will help your application run and make your users happy. So with all that said, let's kind of take a look of about what we're going to go over during this talk. So first, we're going to take a look at some of the key observability metrics that Node provides natively in Node Core, as well as some of the new additions that have recently landed in some newer versions of Node. Next, we're going to take a look at how you can get access to this data if your application is running inside a Kubernetes environment, because it is a little tricky. And after that, we'll take a look at some things that you should be collecting. And finally, we'll end with a demo. Cross fingers for demo gods. Just a quick demo and some of the things that we've talked about. All right. So before we kind of get into this whole thing about observability and all these different ways you can do it, we should kind of define what observability, which is a very tough word to say, is exactly. So according to Wikipedia, it is a measure of how well internal states of a system can be inferred from the knowledge of its external outputs. So what does that mean exactly? So I think in the context of this talk, the internal states would be the functions and the other business logic that's being executed and processed in our application. And the external outputs are the things that we want to look at or observe to see if everything is running as we expect. We can rewrite this kind of as a measure of how our application is running using some metrics that our runtime provides. So with that definition under our belts, we can see, let's see some of the different runtime metrics that Node has to offer natively. And since we know that Node is built on top of V8, oh, actually, that's the drink logo. So there we go. We can access some of this data as well. Okay, so let's see what's first. So first up, everybody's favorite tool to debug issues with. I know it's mine. Maybe not the greatest for production, but console log. It's I was kind of tempted not to put this here, but if I didn't, I think somebody on the internet would probably ping me and be like, oh, well, actually, you can use console.log. So this is here for those well, actually people. So probably don't need to explain how this works. I'm sure we've all had similar statements, kind of like this code snippet where we're going in a function, we're saying here or why are you here, or I didn't know this was supposed to be here. So just to kind of get that first one out of the way, which is, I think, everybody's favorite tool to use. Next up, we have some different ways to do profiling. For those that are new to what profiling is, when talking about coding, a profiler is the analysis software that measures frequency and duration of function calls, as well as making sure that those functions are producing the desired result. So while there are third-party tools that can be used, Node actually has this capability built in, and since we know that it's built on top of V8, we can get access to some of those tools as well. So the V8 profiler allows you to actually sample the stack at regular intervals during the execution of your application, and that will get logged as a series of ticks. This can be done in the command line fairly easily. If you run your application with the --prof flag, it produces a log file. I've shortened the name here just so it would fit on the screen. But that log file also needs to be processed in order to become human readable. So you use the prof process flag and then output it to some sort of text file. So this example right here is just kind of a sample of a section of what a log file could be like. For this particular application, we can see that at the very top, there's this node crypto function that seems to be taking up a lot of time. So, having that knowledge, you can go back into your application, you can pinpoint what's going on, you can make the necessary adjustments. So just as an FYI, this example here is taken from the guide on Nodejs.org about profiling. The reason why this is running so slow is because the call to that crypto function is actually the synchronous call. So switching it to the asynchronous version of it will actually help clear up that bottleneck. So if running the CLI flags kind of isn't your thing, if you're more wanting to do programming instead, you can use the APIs. There's the inspector module, which is inside Node Core, similar to the CLI flags, but you can actually stop and start Profiler from your code, so you don't have to do those flags. This example here that we have is how you might do maybe a CPU profile. It's a lot of some of the obviously the business logic is missing here, but it gives you an idea of what you do. You're requiring the inspector module. You create a new session, you connect to it, then you enable and you start that profiler. You do some tasks, and then you stop the profiler. And then the file that actually gets output is then you can upload that to Chrome DevTools in their profiler section, and you can get a better view of what's going on there. So it's kind of neat to use both of those tools together. Next up here, we have trace events. The trace events module provides a mechanism to centralize tracing information generated by V8 Node core functions and your user code. So tracing can be enabled with the either with the trace event categories command line flag or by using the trace events module. If you're using either one, it actually accepts a list of command line separated categories. So you can actually create custom traces if you want to. But by default, it will just use the regular Node and V8 and some Node async hooks categories will be enabled by default. And like the inspector module that we just mentioned before, if you run the trace, it will actually produce a log file that you can upload to the tracing part of Chrome DevTools, so you can see a little bit better visual view there. So here, and just in this example that we're showing here, we're creating a trace for promise rejections, that category. So this is going to enable capture of trace data, tracking the number of unhandled promises rejections, and handle after rejections. So there's a lot of categories which we're not going to go into right now, but after this talk, I invite you to take a look at the Trace Events API on Nodejs.org to learn more. Right. So next up, we have the perf hooks, the performance hooks module, or also known as the perf hooks module. So these APIs allow developers to set various markers that make measuring the runtime of an application a bit easier. It also provides an implementation of a subset of the web performance APIs, but not all of them, as well as a bunch of node-specific performance measurements as well. Just as a kind of FYI for what it does for the web ones that it brings over is the high resolution time, performance timeline, and user timing. If you're interested in those, but with these APIs, you can measure the time it takes, like individual dependencies to load, how long your app takes to initially start, as well as determining how well the event loop is being utilized and if your asynchronous code is operating efficiently. And then here's just kind of a quick sample of what the measurement of the duration of what a require and would be to load your dependencies. We can see that it uses the timerify function, which is part of the performance stuff, which actually which will time how long it takes for your functions to load. Right. So the slide after this one assumes a little bit of knowledge of the event loop in Node. So while we're not going to go into kind of the ins and outs of the event loop, because there's a lot better talks out there than what I can do in the next couple of minutes. I just want to kind of show this little kind of high level diagram of what it might look like. This kind of like a little high level view of the event loop. So if we're coming in fresh here, all the incoming connections or the data or your function calls and all that stuff, callbacks will all come in through this poll, this poll phase, and then it just goes through the loop. If we had code that was synchronous, it would block the other code. So it's kind of why you want to use asynchronous code. But that's a very quick and dirty, event loop explanation. So we'll just kind of move it. So the whole reason I mention that is because this next section is one of the newer features that's been added to Node. Is the event loop utilization here. I'm just going to abbreviate it with ELU. So this event loop utilization method, or ELU, returns an object that contains the duration of time the event loop has been both idle and active. So it's similar to CPU, but it actually, it's only measuring the event loop statistics and not CPU usage. So it represents the percentage of time the event loop has spent outside the event loop's event provider, which is that poll part that we saw earlier. So no CPU is actually taken into consideration. So this example here that I'm showing has mostly idle CPU, but actually a very high ELU. And that is because the timeout here is being spawned synchronously, so it's going to block everything. So even though the CPU, will be mostly idle, your application still might be running slow. So this is a great tool and a great new addition to be able to determine kind of where those problems are. If you're having, if you're finding that your CPU is low, but your application is still running slow, right? So of course, enough of me talking here. And of course, once you're ready to deploy your application to a container-based platform, it becomes a little more difficult to access kind of these things that we were talking about. So now I'm going to hand it over to Alex, who will talk a little bit about getting access to that data running inside a Kubernetes environment. So Alex.
Yes, thank you, Luke. So one of the most production-ready solutions for monitor containerized applications is the open source Prometheus toolkit. Prometheus is a mature and battle-tested monitoring and alerting tool that provides multiple features, such as dimensional data that can be identified by metric name and key value pairs, a very powerful and flexible query language. So you can merge different metrics together to produce more complex and more meaningful ones. Multiple modes of graphing and dashboarding, although for this one, you'll have to use like a third-party tool, something like Grafana, for example. The nice thing about Prometheus is that you can find integration libraries for all sorts of languages and frameworks, which is something really nice. And one very important detail about Prometheus here is that by default, it uses a pool-based model. This means that you have to provide the collected metrics somehow, like through an API endpoint or something, so that Prometheus can scrape and collect the desired metrics afterwards. Cool, yeah. Okay, so how do we expose some metrics to Prometheus from Node.js? This is a Node conference after all. We use a library called Prom Client that offers a great deal of features. First of all, Prom Client can provide us by default many of the metrics that Luke mentioned before, like garbage collection metrics, event loop lag metrics, etc. We can, of course, create our own metrics that we want to measure. And one nice thing about Prom Client is that it allows us to use a push gateway model if necessary. That means that we can directly send to Prometheus without waiting for Prometheus to scrape them, send data. Now you may wonder, why is this useful? Well, think of the situation where we measure metrics from a batch or a background job. Unfortunately, though, the job does not live enough for Prometheus to scrape the data, but for some reason, we really need to get those metrics to Prometheus. Now, this is where the push gateway comes in handy, because the batch or background job can push the metrics directly to Prometheus right before it finishes. So eventually, Prometheus will get the metrics that we want. In general, though, we use the push gateway method only on edge case scenarios. Cool. I mentioned above that using Prom Client, we can create custom metrics if you want to for our application. But what kind of custom metrics are useful, really? Yeah, so the previous slide. Yeah, so here we have a small code snippet on how we use Prom Client side Node. So we require from Node modules Prom Client, and we say to him that, hey, I want you to collect all the default metrics that you got, and we also add a prefix to our metrics, because why not? And a few lines of code later, we expose those metrics. Now this snippet is from our demo that we'll show you later, and it uses the Express framework. So a few lines later, we expose these metrics through this /metrics endpoint with this redshirt.metrics method. Cool. Let's move to the next slide. Yeah, and if we visit from our browser the /metrics endpoint, this is what we're going to get. Now, obviously, we are going to get a lot more information. But this is something that Prometheus will scrape at the end, and this is something that Prometheus understands. Cool. Now, what to collect? As I said before, we can create custom metrics, but what kind of custom metrics are useful, really? This is the question. So enter red metrics. The red metrics or method defines the 3 key metrics. Well, basically, there are 4, but the following 3 are the important ones. You should measure for every microservice in your architecture. Now, these metrics are part of the 4 golden signal series defined by Google Site Reliability Engineering. So basically, a couple of years back, Google published a book based on their experience about what metrics help them over the years maintain their huge infrastructure. These metrics are the number of requests per second your service are serving, aka the rate, the number of failed requests per second, known as errors, and distributions of the amount of time each request takes, also known as duration. Cool. So just by monitoring only these 3 key metrics, you can deduce a lot about how your application performs in general. Cool. So demo time. Before we start, though, I'll say that we recorded the demo beforehand, but we'll go through it now live because, well, you never know what the demo gods are planning for you. So we wanted to be safe. So before we start the demo, yeah, full screen really helps. Cool. So yeah, if you can pause it right here. Cool. So a few things about the demo. We have an Express application, and we serving two different endpoints. The first endpoint is just an API endpoint. It responds with a JSON object, and also we have two different kind of responses. We have the successful one and the failed one. We use a method that uses the JavaScript date object, so it's random failures, really. And the other one is the /metrics one that I showed you before. So we'll let Prometheus get the data that it needs. So for this particular demo, I'm using OpenShift. It's a Kubernetes flavor of Red Hat because it comes with Prometheus already built in. So I won't have to manually deploy and set up a Prometheus operator. Our goal here is to measure the average request duration and graph it over the last 5 minutes. So here I'm using the Nodeshift CLI to containerize and deploy my application to OpenShift. We can really skip the deployment output here for time's sake. Cool. Now our application has appeared in OpenShift. We're waiting for the container initialization, and our application is running. Now we can go back and get the URL. Here, well, I have to go to the right endpoint, obviously. It's /API/greeting, so you can see our server really responds. And if I actually refresh the page a couple of times, you can also see that I'll also get the error messages. There you go. That's error failure number 1. Cool. And also we have the /metrics endpoint that we are going to get the metrics of our application. As you can see here, also right at the bottom, all this is the default ones. Right at the bottom, we have our custom ones that we want to provide to Prometheus. Cool. Now if I go to monitoring, I can get some basic metrics out of here. For example, CPU usage, memory usage. As you can see, I can also reduce the time frame. Now if you can pause it here, one really important detail is that all these metrics that you are seeing here, it's coming from OpenShift itself. Prometheus, it's not ready yet to run. And OpenShift can give us all this information because we deploy a pod to OpenShift, so he knows the CPU usage, he knows the memory usage, all that stuff. And now I will actually, but this is pretty basic metrics. You can get more custom ones out of it. So now I will resume the video. So I have to deploy a service monitor. The service monitor is just a 10-line YAML file that we specify the metrics endpoint that Prometheus will scrape and the scrape interval and stuff like that. Pretty simple 10-line YAML file. Yeah, I guess we just have to wait until the service monitor is ready. Yeah, you can fast forward a bit, I think. Yeah, cool. Now we're going to stress test our application with Apache Bench. We're going to hit our application with 500 requests, with 100 requests at the same time for each cycle. Yeah, it's pretty fast. It won't take much time. Cool. Now this is done. Prometheus is running, so you can actually get some useful information out of it. So I can go back to metrics again, and now because Prometheus is running, I can run a custom query from application. Now if you can pause it right here before the results, great. So if you look at this query and you think it's like a very strange one, the query is just a mean average calculation with the custom metrics that we collected. So yeah, go ahead and zoom. Cool, and we can see our graph here. I will just set the time frame for the last 5 minutes. Now, the reason we have 2 lines in the graph, it's because we have 2 different responses. Remember, we have the successful one, 200, and the server error response, 500. Yeah, I think this is the demo that I would show you. So let's head back to look for the wrap-up.
All right, thanks. I think I have to exit full screen so you can move to the next slide. Yeah, there we go. All right, cool. Yeah. So yeah, before as we're wrapping up here, just kind of wanted to mention one thing about the this reference architecture that it's not a built-in tool or anything like that for Node.js. It's something that we at Red Hat and IBM here have started to look at and kind of define like what types of things can developers use, and and a lot of these opinions are coming from the different teams that are interacting with all our different customers and seeing what they're doing. So we're working on different things like the observability stuff, the metrics things. It's all, this repo is open, so if you're interested in contributing, I would check it out. Right. So just as a wrap up here, I've added a few links to some blog posts that we've written, some links to Prometheus, the Prometheus client, the reference architecture, and also the nodeshift.dev site that we have. So, hopefully you guys learned some stuff that will help you building your future applications. And thank you very much. That's it.
Thank you, everyone.